All right, so chapter 4, section 2, we're going to prove some of these things now. Side angle side postulate. We're going to treat it as a theorem by proving it instead of just claiming it's true out of nowhere. So, we're given side angle side. So this and this, that and that, and the included angle, not just any angle around here, cannot be one of these. It's got to be the one made up of these two sides. So we have side angle side. Now we're going to go through and prove this. How about if I move this over here, and then I'll just do the proof right here. Put the diagram up like here. All right, so the given is, let's see, we got A, B, C, D, E, F. So we're given that angle C is congruent to angle F. AC and DF are congruent. CB and FE are congruent. Okay. Now, what we do here is, if angle C and angle F are congruent, then we can get this angle and put it on top of this one so that DF lies on AC and FE lies on CB. Okay? So we're just laying one angle on top of another. So we notice that. And then we know that because of the congruences, DF is the same length as AC, so A lies on D. Okay, because this length is the same as this one, so if this line lies on top of it, A and D will overlap. By the same reasoning, B and E will overlap. So so angle C lies on angle F, definition, angle congruence. And then A lies on D. And that's definition of segment congruence. A on D, E on B. And now we use one of our postulates. Remember, A and D are the same here. And 2 points determine one line. So this point and this point determine one line. So this has got to be, AB is congruent to DE. Okay? And so then the triangles are made to overlap. And so by definition of congruence, this one can be made to lie exactly on this one. The triangles are congruent. So we know AB congruent to DE. That's one of our postulates. Let's write postulate. And then line 5 would be triangle ABC is congruent to triangle DEF. Okay? Definition of congruence. Alright. Now, let's prove one of these others. Okay. Angle side angle postulate. So if we've got Okay, we'll prove it as a theorem. All right. So we're going to do something similar. A, B, C, D, E, F. Okay. Now, we know that we're given these things. We want to go from the given to saying that one triangle is congruent to another. That'll be our final statement. So with this limited information, we're trying to show that two triangles are congruent. And that's the whole point. Kind of like in the last theorem. So we take DE and place it on top of AB. Okay. First, let me say the given. So angle B, congruent, angle E, A to D, and AB, DE. I just put a G for given. Now, we get DE and place it on top of AB because they're congruent. So and that's going to be definition segment congruence. Alright. And then, since angle D is congruent to angle A, these lines will lie on top of each other. So we've got F will be along here somewhere, and then, because remember this will lie on here, we pick it up and put it down there. And then this angle we get and put here. The angles are congruent, so they lie on top of each other. So then F will lie along here somewhere, okay? So B lies on E, and A lies on D. Definition congruence angle. Okay. But again, by one of our postulates, just like last time, we have two lines. Two lines cannot meet in different points. Like these two lines cannot meet in point F, because notice they meet, and at C, two straight lines meet in one point. So that means that F must lie on top of C. Okay? Because they meet at F, they meet at C, but these lines lie exactly on these, they meet at one point by our postulates. Two lines meet at exactly one point, two straight lines. And so then, again, we made the triangles overlap. So C lies on F. And that's a postulate. It's one of the earlier ones in the book. And therefore, the triangles lie on top of each other. So, triangle ABC is congruent to triangle DEF. And that's the definition of congruence. Okay. So we'll stop there, and then I'll do the SSS theorem in a third video. Cool. Let me know if you have any questions.